Hello there, welcome back to our channel, and we are going to analyze another circuit. This circuit consists of an amplifier, mainly a differential amplifier, which has a gain of AOL, which stands for open loop gain. So this amplifier is also called as operational amplifier, right? And now what we see, we have an input signal that is applied to the negative pin of this amplifier, and that external signal is UINN, or simply call it as a VIN. Because of that, the current starts flowing into the circuit and is trying to flow through the capacitor. And when the current flows through the capacitor, we see that that current is coming towards this node, and that current is being splitted into two parts. So one is trying to enter the negative pin of the amplifier, and another is making a path towards the output for through this resistor, feedback resistor RF. So there is certainly a negative feedback. We can also say the portion of output is being fed back to the input. That is the negative pin of the op amp. So let us call this node as V1 and this node as V2. And before we analyze and get the expression for the output, which is UO or simply VO, we need to understand how the role of the operational amplifiers open loop gain plays, what kind of role it plays. And since you have a feedback now, the new form of gain will be called as ACL. So this is called as closed loop gain. So we have to understand two things here. One is the open loop gain and another is the closed loop gain. Now I would start applying some fundamentals. So again, let me write here, this is open loop gain. And the value of open loop gain is for the practical amplifiers is approximately 10 to the power 5 into the range, into this range, 10 to the power 5 to 10 to the power 7. So it's pretty high. With that, we know that the output divided by the input is your gain. Okay. And what is VID? VID is the difference between the two inputs that you apply to the amplifiers input terminals. So therefore, we say that VO divided by V1 minus V2 is equal to A. And this is your differential gain, AD. And now this differential gain can be ACL or AOL, depending on whether you operate the amplifier without a feedback, which is then this term, and with feedback, which is then this term. Okay. And usually the ACL is set by the electronic components, passive components using resistor, capacitor, and the inductors. And of course, in the open loop gain, you don't have any feedback. That's why we call it as an open loop. So when we say that the AD is very high, we can also write VO divided by AD is VID. And we say that when the AD is very, very high, when AD is very large. So right now we've seen that this is the range that the AD. It means the VID is extremely small in the range of microvolt or even smaller, or maximum in the range of millivolts. In ideal situation, we say that ideally we want AD to be infinity. So when such situation happens, we say that output divided by the gain infinity has to be zero. So it means VID has to be zero. So when VID has to be 0, we say that has to be 0 if the gain tends to infinity. It means you can write here V1 minus V2 is equal to 0. It means V1 is equal to V2. That means your voltages at both the nodes, at the negative and the positive inputs of the amplifier, are at the same potential. So we say that V1 is equal to 0 here because it is connected to the ground, as you can see. Therefore, the V2 comes at the same potential, and we say that as if there is this virtually short circuit between V1 and V2, and this is called as virtual short concept. So this virtual short concept helps us to approximate our analysis when we simplify the circuits or simplify the circuit analysis. Now, with that said, now let us apply at the node V2. Apply KCL, Kirchhoff's currents law. There are two laws, KVL and KCL. So we are going to apply KCL at node V2. And with that, we will say in sum of incoming current, I and N, is equal to sum of outgoing current. So we are assuming this IN is equal to 0 and this IP is equal to 0. These two are the currents with the assumption that the differential input resistance RID of the amplifier is equal to infinity. It means the amplifier is not receiving any currents through the negative and the positive pins of it. So IN is equal to 0, which is the current inside the negative pin of the amplifier, and the IP is the current trying to enter to the positive pin of the amplifiers. They are all equal to 0. And therefore, the only component that is left now is the IN, and it is just going through this feedback resistor RF. So that's why I have written IN is equal to IR. So IN is actually the current through the capacitor. Now the current through the capacitor IC is given as dVi over dt. So the rate of change of input voltage multiplied by the capacitance value gives us the value of the current flowing through the capacitor. Now the rate of change of input, so that is the voltage here is the V in. So we can write now UINN minus 0. That's the voltage difference between across the capacitor. Okay, V2, remember V2 is at 0, divided by, well, we have to write this, actually this the capacitor. So it would be like derivative of this voltage multiplied by the capacitor is equal to 0 minus, that's the value of IR, is UO. UO is your output here, divided by RF. Simplifying this gives you the value of C DUINN divided by dt is equal to minus UO divided by RF. So that's the kind of expression you get. Now we need to simplify it and express the relationship between output and the input. So we can write here UO, which is an output, is equal to RF times C, derivative of UINN over d over dt, and there will be a negative sign, right? So we can simply see that RF and C makes a constant. These values are constant, and the output voltage is the negative derivative of the input, right? So if you apply a constant voltage of 1 volt, so let's say you have a constant voltage here uh, at time t equal to 0, and we say that the output for that output of the derivative constant is equal to 0. The output will be 0. And if you have a time varying signal, for example, you apply a sinusoidal waveform, accordingly, the derivative of sine wave will be obtained here. That will be a cos. So this is how we basically see that. So this circuit is also called as differentiator. Differentiator using op-amp, using operational amplifier. So it's basically making you, helping you to get that. So that's all. So we have seen comprehensively how to obtain the expression for the output, and that is how. So you choose the value of resistor and the capacitor, and accordingly you will have the output expression. So in case you have a questions or comments, you can write them in the comment sections. You can like the video if you did so, and share it with others for a wider reach. Stay tuned for more engaging and simplified concepts like this, and till then wish you happy learning. Don't forget to subscribe to our channel.